Hello everyone, this is Group 16 and we will be presenting our project on compostable paper packaging. Packaging waste contributes to nearly 30% of the municipal solid waste in the United States, and a large portion of that waste is plastic. Plastic is one of the most common types of packaging materials due to its excellent flexibility, low cost, and high durability. Unfortunately, plastic does not biodegrade quickly and is not recycled enough, so it usually sits in a landfill or ocean, polluting the surrounding environment. Plastic packaging is also sometimes combusted after use, which releases toxins into the air that can cause respiratory problems and even cancer. The goal of this project is to develop and test an alternative to plastic packaging that retains all the strengths of plastic while also being compostable. Our team selected and tested the combination of paperboard and craft paper coated with polyvinyl alcohol and MMT to determine how viable of a plastic replacement it could be. Both paperboard and craft paper possess stronger physical properties compared to normal paper, while also being completely biodegradable. The PVA MMT coating adds to the paper's mechanical strength while also providing improved barrier properties and flame retardants.
Selection of a proper coating technique and the process of cross-linking is vital for the coating's ability to properly bond with the substrate, as well as improve barrier properties. Several types of coating processes were available to the team, including dip, spray, and rotational. For the experiments, the team used dip coating, as it is most efficient for the relatively small and uniformly shaped substrate samples we applied the coating to. However, in large-scale operations, dip or rotational coating may be more viable in order to coat large packaging or pre-made packaging that is not uniformly shaped. During the coating process, PVA and MMT are dissolved into an aqueous solution and allowed to disperse, with assistance from sonification. Addition of substances such as glutaraldehyde allows for cross-linking between the PVA and MMT. This helps to improve the mechanical and chemical properties of the coating and also improves water stability of the coating. Our team chose to coat samples of craft paper, fiberboard, and chipboard in both a PVA-only coating and a PVA MMT cross-linked coating in order to compare between coating types and against uncoated paper samples. Both the water vapor transfer rate and oxygen vapor transfer rate of all the samples were tested in lab. Unfortunately, the oxygen vapor transfer rate was still too high to be accurately read by instruments available to the team. However, the team did see a remarkable decrease in the water vapor transfer rate in each sample. The PVA MMT coated craft paper fell by approximately 93% compared to the uncoated craft paper. This brought the samples to a level comparable or better than many common plastics. The fiberboard and chipboard samples also saw a reduction in water vapor transfer rate. Unfortunately, the uncoated and PVA-only coated samples remained too high to be measured, somewhere above the 10,000 grams per meter squared per day mark. However, the PVA MMT coated samples were measured to be approximately 380 and 312 grams per meter squared per day. This means there was a minimum reduction in water vapor transfer rate of around 96 and 97% for each respective sample.
Compostable paper packaging comes with benefits for the environment. Since the test the team did were using a home compost bin that was purchased off of Amazon, most consumers should be able to compost the packaging on their own. Even if the packaging were to make its way into a landfill, it will still have the ability to break down or biodegrade. This is contrasted with plastic packaging that can get stuck in landfill or has to be burned in order to be gotten rid of. This can lead to the release of harmful pollutants into the air. However, the production of paper itself can have a negative impact. Paper that is not properly sourced can be the result of unsustainable deforestation. Paper and pulp mills also use large amounts of water, with most mills using around 17,000 gallons of water per ton of paper, and the most efficient craft paper mills using around 4,500 gallons of water per ton of paper. The EPA reported that in 2018, paper and paperboard containers totaled around 41.9 million tons of the municipal solid waste.